In this video, we're going to walk through the Microsoft Lab talking about how to manage and control traffic flowing in our Azure deployment by using routes. Now, if you're familiar with networking in the past and you've worked with network gear such as Cisco or other equipment, you may be familiar with the idea of a route and how a route helps traffic go from one place to another. Same thing happens here in Azure, but it works a little differently. So let's go ahead and get started. Here in the introduction, we start talking about how a virtual network allows you to set up some perimeter security around your environment. For instance, here we have a situation of a retail organization. You recently suffered an incident and therefore you need to secure the environment. And so you start coming up with some remediation plans to help add network permissions or protections in the form of what's called a network virtual appliance, or an NVA. As you're moving into Azure, you're going to put these NVAs into your Azure environment. Here's where we start talking about what our Azure routing capabilities are, and it starts talking about the various routing. As we start off, you're going to be fairly understanding. You're going to have some networks and some hops, or the next hop. In Azure networks, there's a couple of different routes that we start to work with. First is what's called a system route, or a default system route. Now, the great thing about default system routes is everything inside of a VNet in Azure can talk to everything else that's in that same VNet in Azure, thanks to the default system route. And pretty much anything that has this kind of an address, either 0000, 10.000, 172.16.00, 192.68.00, or 10.64.00/10, anything that falls within those ranges automatically get a default system route. So the default system routes automatically allow everything inside of a VNet to communicate with each other when we can't override those. Can't remove them, we can't recreate them. However, we can create a more higher preferred route above those. Here's an example of a VNet. The whole thing is one simple VNet. If you're not familiar with the idea of a virtual network, this would be the equivalent of, say, a building or a data center. So you would create the entire building or data center into one large virtual network. Inside of that, you break it out into separate separate subnets, all based on their role or purposes. And because this is a 10.something network, there is a default system route that connects the two networks together, as well as connects them out to the internet. Virtual network peering and service chaining. In this scenario, we have a slightly different scenario, a slightly different situation, which we won't cover in this lab. But in this case, what we have is, instead of having different subnets like we did before, here we have different virtual networks. So instead of routing, and specifically these default system routes, what you'd have to do is you'd have to set up VNet peering to allow the different virtual networks to communicate with each other. This is not set up by default, and therefore will require you to do that manually, but that is in a different lab. Virtual network gateway, that's another endpoint. There we go. Custom routes. So custom routes help you quickly get your environment up and running. This default system routes work pretty well, but there's times where you want a user-defined route. There's two types of custom routes. There's the user-defined routes, which we'll be using here, and then there's also using BGP. Now, the rule number one when working with BGP is, if you don't know what you're doing, don't use BGP. Therefore, we won't be talking about using BGP to configure our custom routes. Instead, we'll be using a user-defined route, which can be used for, well, pretty much most everything we just looked at. For instance, we can send people out to the internet. We can send things from one virtual network to another. We can send things through a virtual network gateway, such as a VPN device, or even a virtual appliance, such as a firewall. If we really want to, we can even configure a custom route to send traffic nowhere. With BGP, pretty much the same thing, except you have to configure BGP for your environment. And then there are a few details with regards to route selection and priority. First off, we see the priorities of the routes down here. Very first, a user-defined route. If a user-defined route is identified, that will be the first choice. If there's no user-defined route for the traffic you're sending, it will then look for a BGP route. If there's no BGP route, then it will go to the default system route. A little bit more specific with regards to the user-defined routes. Up here we can see the Azure routes to the longest prefix match. For instance, we can see we have traffic targeted for 10.0.0.2. And now there are two routes available. There's a route for 10.0.0.0/16 and 10.0.0.0/24. The /24 is longer, has a longer prefix. 24 is higher than 16, therefore it's a longer and more specific match, and therefore that is the one that will win. All right. Let's go ahead and get started. Let me activate the sandbox here. That will take a couple of minutes. What we're going to do is we're going to build out this lab environment right here. Let's actually open this in a new tab and look at it. What we're going to do is in this environment, we're going to have our public subnet. And the idea here is that this would be the internet or wherever our clients are who want to connect to our systems. So that is where a PC will be. And then on our private subnet, we will have a web server or some other server in our private subnet. Now, by default, because all of this is within one virtual network, the default system routes will allow that PC to access that server, but we don't necessarily want that. What we want is we want to set up in the DMZ subnet another server, specifically an NVA or network virtual appliance of some sort, that intercepts all of the traffic going for the private subnet. So that when somebody from the private subnet wants to talk to the private subnet, they have to go through our DMZ subnet and then into our private subnet. So the NVA can monitor and filter out all of that traffic as it goes through. So let's get that set up. All right, sandbox activated, Cloud Shell's loading up, that's great. First thing we're going to do is we're going to create our route. So with the Azure CLI here, we can read these kind of from the right to the left. We have create route table in our Azure network. We're going to create this route table. We're going to call it public table. The resource group it's going to is that one right there. And then we're going to specify, let's go ahead and disable BGP. So that route table, if I look back at my diagram, that's going to be this routing table right here that we're going to say anything that's destined for 10.0.1.0 needs to go through 10.0.0.2.4. All right, let's go ahead and copy and paste that and run it. So that will create my route table for me and begin to prepare me for my configurations. Now that we have created the route table, now we can go ahead and create a route into that route table, which is what the next command does. We're going to create this into the public table that we have just created. We'll create a rule called production subnet. If somebody's trying to go to this destination, 10.0.1.0, then they have to go to this IP address, which just happens to be a virtual appliance type. So let's go ahead and copy and paste. Again, if we look back at our network diagram, that is going to be exactly what we just said. So we've got our NVA over here in the 10.0.2.0. By default, that's going to end in .4, so 10.0.2.4, just because that will be the first machine that we create on there. And we're saying, hey, if you're going to 10.0.1.0, which is my private subnet, you have to go through 10.0.2.4. So we just created that routing table. We just put this route in there. And it succeeded. Great. Now that we've created those routes, well, now let's create the virtual networks for them. That seems a little backwards. We created the routes before we created the networks. That's fine. The command here, again, if we read it from the right to the left, we're going to create a virtual network in Azure. We're going to be really silly on our naming scheme here, and we're just going to call this VNet. That's not a very descriptive name, but that's what we'll go with. So we're going to create a virtual network called VNet. We're going to give it a 10.0.0.0.16 range. And in there, we're going to create our first subnet called public subnet with our 10.0.0/24 range. So we'll go ahead and run that. And when that's done, we'll run this next command, which will create an additional subnet on that same VNet. So create subnet in our VNet. We want to create this subnet called private subnet, and we want to add it to that VNet that we just created, the VNet named VNet. In this case, with a range of 10.0.1.0, copy and paste. And then we do the same thing for the DMZ subnet with the name DMZ subnet. All right, and when that's done, we should have one VNet with 3 subnets inside of it. If I go ahead and paste this command here, it will list those out for me in a nice table format. And we can see, yes, there's a public subnet, a private subnet, and a DMZ subnet with the appropriate IP addresses associated with them. All right, so at this point, we have created a routing table. We have created a VNet with some subnets, and now we can go ahead and associate the route with the subnet. So what we want to do is we want to specifically tie this to the public subnet. So we can see our command here. We want to update a subnet in a VNet. Okay, which subnet? Well, the public subnet. Which VNet? That VNet. And what do we want to update? Well, we want to add a route table to the public table. So the routing table we just said before, it will now be assigned to the public table. I'm sorry, to the public subnet. And that finished. All right, next page talks about what an NVA is, or a network virtual appliance. And it actually has a few really great examples right here. Probably the most common one you might see would be a firewall. Some sort of an application level firewall that's able to identify the type of traffic coming through it and inspect it to make sure it's well formed, say HTML code or other application specific protocols. Other NVAs, such as a WAN optimizer, some sort of an application delivery controller, routers, load balancers are a great example of an NVA, as well as IDSs and proxies. They actually have an example, I think if we look through here, there we go. Network diagram of what might be a good example of an NVA, to where we have people coming into this environment and they're hitting a private DMZ zone. In this case, there's a private DMZ zone in and a private DMZ zone out. So what might be considered an inside as well as an outside. In this case, it would actually be swapped around. And so what happens is as traffic comes in, it goes into the beginning of the DMZ zone and starts working through these NVAs. Now these NVAs are set up in an availability set so that there's always one or more available. And only once the traffic has successfully passed through the NVA and met whatever firewall or IDS or load balancing rules that are in it, does it actually go through the other side, up in this case, up into the web tier, and then the business tier, and then the data tier. So an NVA, like we said before, can be any of those components: firewall, router, proxy, right? And then this is normally how you might configure that in your environment. All right. So the first thing we need to do is, well, deploy our NVA. So we've got our network here. This is what we've already created. We need to create this NVA right here. Now, we could actually go into Azure, and we could say specifically, hey, I want this particular NVA. There's a lot of NVAs out there that we can pull from, such as IDSs and firewalls and so on. For this particular scenario, we're going to create a very basic NVA utilizing just a Linux machine. So let's go ahead and copy and paste this in. I'll talk about it here in a second. First thing I want to do is I want to delete where it says password with the brackets around it, and I want to replace it with my own password. So password 0123. Don't use that in a production environment. Bad password. While that's running, if we look through the command, this command is creating a virtual machine in this resource group. We're going to name this NVA because we're just not really that good at having creative names at this point. So our NVA virtual machine is going into our VNet, specifically the DMZ subnet inside of our VNet. This will be running an Ubuntu LTS image and we'll create a user called Azure user with a password of password 0123. So that just finished, and we can actually see over here on the right hand side, this guy right here. That's exactly what I was looking for. The very first machine you put into a subnet will oftentimes get the .4 address. So we can see here 10.0.2.4. If we look back to what we had for our routing tables, we actually referenced 10.0.2.4 for our NVA. See, it says run the following command to retrieve the public IP. I can see the public IP right here, but we want this to actually store it into an IP, into a variable called NVA IP. So I'll go ahead and copy that and paste it. There we go. And then it saved it as an NVA IP variable, which I then did an echo NVA IP, and it spit it right out. All right, so now on this Linux machine, we need to enable what's called IP forwarding. Basically, there are two different network cards on it, one network card that we want to be able to route data through. And in order to route data through this, we need to enable forwarding of IP packets. So what we need to do is first get the NCC IP, get the ID of the NCA. Let's see, it's going to list the network card in Azure and then save that as a variable called NCC ID. Let's go ahead and see what that is. Sorry, NIC ID. There we go. So that is a unique ID for the network card. Then we want to find, looks like the NIC name. So we'll run that, which is called NVA VM NIC. And then we want to update it. So we can see here, update NIC in network in Azure, specifically this NIC name, the NVA VM NIC that we just created. And we want to set IP forwarding to true. So I'll go ahead and run that. If this is the first time you've seen IP forwarding, basically it means let this machine work as a router. And so this is configuring the network card to work as a router. All right, that's taking longer than expected, but while that's going, let's go ahead and just log into the Azure portal and we can actually start seeing all of this stuff as we're setting it up. If I go into all resources, then I should see, as I scroll down, I can see my NVA virtual machine and other components of the NVA. I can see my VNet, and if I clicked on the VNet under subnets, I'll see my 3 different subnets. If I go back to all resources, I will have seen down at the bottom there my route table called public table with the routes defined right there. Yay! So everything we have just completed is now in the environment. And that is taking its own sweet time. All right. Once that's done, so that's updating the NIC as far as Azure is concerned. Once that's done, we then need to actually update the operating system on the Linux machine. So in order to do that, again, we'll need to get the NVA IP. So we'll get the public IP address of the NVA machine. And then we will SSH into it. We'll actually connect into the Linux machine, logging in as Azure user. And we will run the command sudo syscontrol -w and then net.ipv4.ip forward equals 1, and then log out. So that will essentially log into the machine, set this flag that enables IP forwarding in the operating system, and then log back out. All right, since that is taking a while, I'm going to see if I might be able to open up an additional console session here. So what I did just through the Azure portal, I clicked this button right here, which opened up another Cloud Shell. It's the same as the Cloud Shell we're seeing here, which is now responding. It was just a separate instance of it. All right, since that's responding, I'll stay here. We'll go ahead and get the NVA IP. This is running the list IP addresses command in Azure in order to find the IP address for the NVA. It will then echo it out for us so we can see it. Let's see right there, 104.42.43.176. Great. We're now going to SSH into this machine and immediately run that command and then exit out. So it will prompt me for the password. Password 0123. Run the command and then log out. Quick and easy. It makes it really nice that I don't have to actually log into it and run the commands. It just runs and finishes. All right, so we've created the NVA, we've created the networks, we've created the VNet, and we've created the rule. Now we actually need to create these 2 virtual machines, both the public and the private virtual machine, and then log in and try to browse them. Okay, so we start off, open the editor and create a file called cloudinit.txt. Code is a text editor that we can use through the command line here, and we will create and edit a file here called cloudinit.txt. So I'll paste that and enter, and we'll see that there is my text editor right up here. What I want to do is I want to copy and paste this stuff in here. I can't right click and paste, that's not an option. I have to actually hit Control V, but it does paste it in. What this is a configuration that will help automatically configure the virtual machines with specific packages that I want. In this case, the traceroute package. So I've gone ahead and I've pasted that in there. I can see the little ball up here next to the name, which tells me that the file has not yet been saved. I want to click the 3 dots over here on the right hand side and say save, and the 3 dots and close. So I've now created a file called cloudinit.txt. And now I want to create an additional virtual machine. In this case, I'll call it public. I'll put it on a VNet called the public subnet. Again, Ubuntu LTS with the Azure user. And I'm going to tell it, go ahead and use this custom data when you're building it out. So use the information we just saved in that text file as you're building this VM. It will prompt me for the password, and then it will also include this no wait command, which means it won't wait until it's finished. It will simply run in the background. So we'll paste that. I'll go ahead and type in my password here. password 0123 and enter, and it starts the VM creation process, and then comes back. At the same time, we now also want to create an additional VM, this time private. Same configuration, including the cloud init, except this time on the private subnet instead of the public subnet. Copy, paste. And there we go. At this point, I'm going to go ahead and run this watch command. And what we're doing here is we're running the stuff that's in the red here. This is doing a list of the Azure VMs. Specifically, it is looking for provisioning state. And then it's running this every 5 seconds. So the watch command will run every 5 seconds, and we can actually see the timestamps up here. And what we're looking for is, well, we're looking for a succeeded state on all of that. There we go. See, the NVA succeeded, public succeeded, private is still in process. So we have to wait a few seconds more, and it has gone ahead and updated to succeeded. Now that everything is succeeded, I can go ahead and press Control-C on my keyboard while clicked into this window, and that will stop the watch statement. All right, and now I want to get the IP address of the public virtual machine, because now I want to start testing my routing. So we'll go ahead and run that command. Again, we list IP addresses for our virtual machines in Azure, specifically looking for the public virtual machine, and it returned back the IP address 40.83.210.194. We saved that in a variable called public IP, and now we can keep using that public IP further on. Let's do the same thing for the private IP. And we can see, hey, the addresses aren't really that far off from each other, but close enough. All right, so now we've got our virtual machines created. We've got our VNets created. We've got our subnets created. We've got our NVA created. We've set up our routing table. And in theory, everything going from public to private should go through the NVA. Let's test it. What we want to do now is we want to log into the public environment, and we want to try to route traffic to the private. So here I'm going to use SSH, and I'm going to log in with Azure user at my public IP address. I'm going to run the command traceroute, and we're going to traceroute to the private IP. If you're familiar with traceroute, what it does is it allows you to ping or try to communicate with a remote device, and it tells you which hops it takes along the way. So this is going to essentially try to ping the target of 10.1. What was my network target there? 10.104. Yeah, 10.104. It's going to try to ping 10.104, but the routing rule should make me go through 10.024. And we can see right here, the very first hop is 10.024, which is my NVA. And the second hop is 10.014, which was my destination, which was my private machine. And there we go. We can see the example of exactly what we were looking for. And there we can see a really nice diagram explaining what's happening here. Yeah. So as we were here on the public machine, we said, hey, we want to ping, or we want to connect with the private VM. So the very first thing we did was we looked up at the routing table, not the virtual machine, but Azure. Looked up at the routing table and it says, oh, well, you want to go to 10.010? You have to go and talk to this guy first. So Azure routed us through to the NVA. Now, we went through a couple of extra steps on the NVA in order to configure IP forwarding, so that once the traffic was sent to the NVA, it turned around and then forwarded it on to the destination. Now in this case, it seems a little absurd for us to have turned on IP forwarding on the NVA, but remember at this point, the NVA, we are simulating maybe an IDS or a load balancer or some other network device, and we're just simply using a Linux machine in order to do it. All right, so we did public to private up here, and now it's saying, hey, let's go ahead and do the same thing, except this time from private to public. So we're going to log into the private machine. We're going to run the same trace route, this time trace route to public, and we'll see how the destination is different. Yes. So before, when we went from private to public, it took us 2 hops. We had to go through the NVA because the routing table told us to go through the NVA. When we went from private to public, just 1 hop. We talked directly to the destination because there's no routing table, no custom routing table telling us to go through the NVA. And there we can see step number 1, we did a lookup for the default system routes. The default system route said, yeah, go ahead and just talk right to them, which we did. So there we have it. That is setting up and managing traffic inside of our Azure environment by utilizing routes. This was a fairly small configuration, but we could definitely expand this as we get into larger roles, such as when we looked at one of the earlier units there. In the what is an NVA example, here everything in the blue on the right hand side is one single virtual network. So by default, the system routes would configure everything as one single network and everything would be able to route to everything else. Instead, what has happened is customized routes, like what we just created, were configured to allow some networks to communicate directly to each other, like these guys. But other networks were configured to not talk to each other. For instance, the gateway subnet cannot talk directly down to the data tier because the routing table was not configured for it.